Everyone, we will solve this today's LeetCode problem. The question is a build a matrix with conditions. It's the LeetCode hard. Let's what the question is asking. So we have given a positive integer k. You're also given a 2D integer array, a row conditions of size n, where row condition I represents above I and below I, the number, right? And also given a column conditions of size m, where column conditions representing the left I and the right I. We will see what this above, below, and left, right means here. So the two arrays contains integers from 1 to k. You have to build a k cross k matrix that contains each of the numbers from 1 to k exactly once, and the remaining cells should have value 0, right? So basically we need to form a k cross k matrix, and we have a given a k integers, right? And this k cross k matrix will contain the numbers from 1 to k and can also possible a 0, right? So 1 to k will be there in k cross k matrix, and 0 can also be there, right? The matrix should also satisfy the following condition: that the number above I should appear in a row that is strictly above the row at which number below appears for all I is equals to 0. And the same for number left, that the number which is at left should be appear strictly left of the column at which the number right appears for all I. And we need to return any matrix, right? So basically the question has that we have given a conditions for the one condition is row conditions, and what basically the row condition is that it has given some numbers which is representing above and below, right? What is it representing? It is representing that suppose this is given like 2 and 1, so this is representing that 2 will be above and 1 will be below. In the relative order it will representing this, right? And in the column condition it is representing that the column condition is representing that this should be left and the right, right? First is the left and second is the right. What does it mean? Suppose suppose this is given like 4 or 5, 5 or 8, right? So 8 would be at the right of 5 and 5 will be the at the right of 8, left of 8, right? So this is the meaning of this, right? So we have given some conditions that this condition should be follow when we place these numbers in my matrix, both row conditions and the column conditions, right? And we need to fulfill these conditions and put all the rows in my matrix, and but whichever cells we are not able to fulfill we place 0, right? If you solve yesterday's problem, that was the problem, same as problem that if we don't able to place any numbers and after the following conditions we place 0, right? This is the same pattern, but these conditions are their conditions are very different, right? Conditions are, there are two row conditions, the column conditions, and there are very many conditions here, right? So let's see the first example. We will better understand it. So this is given row conditions and the column conditions, and k is equals to 3, right? K is given as 3. It means we need to form k cross 3 k cross k matrix, right? And it means 3 cross 3 matrix, right? So for forming 3 cross 3 matrix, I need to satisfy this condition. What is the condition? That this 1 and 2 and 3 2, right? This 1 2, 1 would be at the above and 2 would be at the below. Same for 3 2, that 3 would be at above 2, right? 3 will be above 2 and 1 will be above 3. So 1 3 is above of 2. But we haven't given conditions of for any 1 and 3, right? It means 1 3 can be either above 1 or 3 can be below 1, right? It is not given that one conditions between 1 and 3. We have given just conditions of between 1 2 and 3 2. It means 1 3 will definitely be above 2, right? So this is the row conditions, right? And if we talk about the column conditions, let's see what the column conditions would be. So this is representing left, right? This is representing left, right? So 2 1 and 3 2, it means 2 would be definitely in the left of 1, and 3 will be in the left of 2, right? In the left of 2. So but we haven't given a condition between 3 and 2. It means this 2 and 3 is interchangeable. Either 3 can be after 2 and 2, or either 2 yeah, 3 can be 3 can be before 2, right? This both is true, right? Also in these conditions, this 1 3 is also true, or 1 uh, 3 1 2 is also true, right? 3 1 and 2 is also true, right? This, so basically see, we have these two conditions possible for above and below, and we have this two possibilities for representing in horizontal, right, in the column conditions. So but the thing is how we will place it, right? So one matrix possible which is given in our example is that, see, if you see, one is in the, one is above of 2, it is following. 3 is above of 2, it is also following. 2 is above, 2 is left of 1, which is also C. 2 is above, 2 is left of 1, and 3 is left of 2, which is also correct, right? So we have given, can form this matrix. So but you see that we have following two, we have can have two row conditions like this and two column conditions. It means we can form another matrix also, right? So one matrix is this possible, and another matrix what can be possible. So see, this can also be possible, right? So either 3 is above or 1 is above, so let's put 1 is above, right? Now either you can put uh, 0 or here, or 2 will be at the last for sure, right? 2 will be at the last for sure. So one, there can be possible that 3 2 is left of 1 and 2 3 is left of 1. So either you can place it 3 here, right, because 3 is above, and we can place either 3 or 2 in the left of this, so we will place 3, and this is 0. Same for 0, this. So 2 can be placed here, and this is 0 again, and this is 0 again. So if you see, this matrix is also possible because 1 is above of 2, 3 is above of 2, row condition satisfied. Column conditions, 2 is left of 1 and 3 is left of 2. Okay, 3 is left of 2, so it is not satisfied. It means this should be here 3, and this should be 0, and this is here, right? Now this is satisfied, 1 3 2, right? So basically if you see this 3 1 and 2, this, it is representing this second one column, this row, the above below 3 1 and 2, and this 1 3 2 is representing this row condition 1 3 and 2, 1 3 and 2. Same for this 2 3 1 is representing this. See, uh, 1 3 2 and 1, 3 2 1 is representing this. If you can see, this is 3, this is 2, and this is 1, right? This is representing this representing this 3, then 2, and this one. When you move from left to right, the first number you will get 3, the second number you will get 2, and the third number you will get 1 other than 0. So this is representing this condition. And this one, when you move from top to bottom, 1 you will get, then 3 you will get, and then you will get 2, so which is representing this 1 3 and 2. And if you see in this example, first is 3, then 1, and then 2, which is representing the second one. And if you see in this from left to right, you will see, then you will getting 3 2 and 1, which is also representing this column condition, right? It means it means we need to anyhow follow the follow the we need to anyhow make the the following order for above, below, and left, right, and make the matrix by following these orders. Make the matrix by following these two orders, right. So basically it is just representing 1 3 2, and this is representing 3 2 1. Now when we have given some condition like 1 2 and 3 2, right, this row condition is representing above, below. So let's take this above, below condition, right? Let's suppose we have given something like 1 2 3 2, 4 5, then again 2 5, right? Something like that, right? So if you see, this 1 is above of 2, right? So let's represent that above part is left and 2 part is here. So it is something like, don't you think it is something like tree like structure? This is above and then below, right? See, 1 is at above and 2 is at below, right? 2 is at below. Same for 3, 3 is above and 2 is below. It means 3 can be placed here, right? And 2 is below. Same for 4 5, 4 5 can 4 is above, 5 can be at here, right? And if it 2 is above and 5 is here, it means 5 can be right down to here, right, in the below, and 4 can be placed without connection with anyone here, and 4 is 5 is representing here. So if you make an edge if you make an edge with all of them, it is something tree like structure, or you can call as it as a graph. It is graph, right? It something is like graph. It is something like graph, right? It is something like graph. And if you see, this is following some order. This is following some order: 3 1, then 2, then 4, then 5, right? And if you see, we can have multiple conditions possible: 1 3 2 and 3 1 2, like. And this is the for row condition, right? This is for row condition. Same can goes for column conditions. Same can go for column conditions, right? It can be go from left, right? Now, when you will see, uh, let's take this as a left right also, right? We have taken it as a above below. Let's take it as a left right. So one is representing left and two is representing right. So don't think it as a left right, think it is as a graph like structure, right? We will make this graph according to this only. So basically, if you make this as a graph, so this 3 1 2 4 5 just represent like this in the left right also, right? Okay, this whole not copied. Let's copy it. Let's copy it, right? 3 1, right? So don't think it is at our part. Let's think it as a horizontal. Don't think it as a don't think it as a vertical. Think like a horizontal, right? So basically, if you think like a horizontal, this will follow some order, and this will also some follow order, right? So basically, what the order can be followed. So the first element is can be 3 1, right? So either this 3 or 1 can be possible, or this is 1 or 3 can be possible. Two possibilities, right? Again, we can have again two possibility after removing this 3 1. This 2 or 4 can be possibility, right? So after removing this 2 and 4, this 2 and 4 can be possibility. So either you can write like 2 or 4, or you can write like 4 or 2, right? This 2 is possibilities, right? And same for again 1 3 2 4, right? It is also possible. It is also possible 3 1 4 2. It is just like combinations, right? It is just like a combinations, right? Because order can be anything now, but this must be following some order, right? 1 3 would be at can be first, or 3 1 can be first, right? Either after this 2 4, 5 will definitely come. So 5 will definitely come, right? So what is it representing? What is this representing? This is just a representation of the order in a one order, in order of above, right? Above to below, above to below, above to below. And how will this order come? So if you think any algorithm, like how will this orders come? This is something like topo shot, topological shot, right? The we will start from the degrees where it is 0, then 3 1 removed, then 2 will 0, then 2 is 2 4 0, and then follow 5. So 3 1 2 4 5 is following order. Same for column conditions. Same goes for column conditions. But just the thing is that this is above below and this is left right. So same order, if you follow, if you follow same order, we will get the same thing. This we will get the same thing, this. And this is for left to right. And what is it is representing? This is representing that if we move to from left to right, the numbers which came in that particular column, in first column then second column, that can be in order, right? This 3 1, this 3 1 can be possibilities in that it is present in the first column if there is no conditions of above and below, right? So this 3 1 can be possibilities that it can be possible, it is can be in first column. So this 3 1 can be either written as 3 1 or 1 3, right? Same thing like either you can write like 3 1, this 3 1 in the first example which is given, or you can write it like which I have made here 1 3, right? Right, the same things happening. So basically, we just need to make this order for both of them, for above to below in one order, and from left to right in one order. And what we need to do, we just check that at which position this row order, this row order, sorry, this is column order, this column order, this column order, and this row order, the number is equal. If the number is equal, we will assign that value to in our matrix, and if there is no, then we will just place 0, right? And why I'm doing that, see. So if you see the first example, the same example, this 1 3 and 3 2, which we have taken here, right? This we have taken, right? So if you see, let's take let's suppose this is the 1 3, sorry, this is 2, this is 2, and this is 0. Let's take this as for above to below order, 1 3 2, right? So let's take as a 1 3 and 2. This is row order, right? That is the order for row order, right? This is the row order. And for column conditions, let's just take this as a row order, 3 to 1, right? Let's just take 3 to 1. So we have taken 3, okay, 3 2 and 1, or you can take 2 3 1, whichever you want, right? I'm just showing that how this is working, right? How this is working, right? So we have given this row order and the column order. One thing is for sure, that this one will be definitely present in my first row, because it is from above to below, it is representing from above to below. So this is must be at first row, this must be at first row or second row, then this is at third row. Same goes for column order, this will be at from left to right, so this will be present from left to right, right? Now when we move to from above to below, we will check for rows. So this one, if it is matching with any of the column, we will just place from ith to jth column, right? Basically it is representing ith and jth column, na, right? So this is at 0 point, right? So this 0, this is 0th, and whether this 0th is equal, no it is not, so we will place 0. Same 0th and 1th column, it is equal, no it is not, we will place 0. The same, it is same like the yesterday's question, right? It is now representing the same like the yesterday's question. We have just make this an in order using topo for above to below and left to right, and now we are just matching with this 0th to column order, that if it is matching, if it is matching, then what we do, we will just place at that ith and jth cell that the same value. If you see this, and also why it is working, yesterday you remember that the numbers are all are distinct from 1 to k, right? If you see here, the numbers are all are distinct. This is 1 to k, and the numbers are all are will be distinct, definitely for sure. The numbers will be definitely be distinct, then it will be I think it will work, otherwise it will create some problems, right? So this one and this one is at the ith and jth, so it this will one will be present at this jth column and 0th row, right? Same goes for 3. This 3 should match with the column. If it is matching, we will place, otherwise we will just put 0. Same goes for 2. If it is matching, we will place 2, otherwise we will place 0. So this is 0, this is 2, and this is 0. And if you see, this 1 3 and 2 is the same order which we have followed the previously. See, the first condition satisfied, 1 is above 2, 3 is above 2, 2 is left of 1, and 3 is left of 2. All conditions satisfied, right? So basically what will be the final approach here? So how we will get to know that? First thing is, how we will get to know about topo shot? Because we get to know about topo shot because we are seeing that there are some condition representing tree like a structure, graph like a structure, right? And also if you think the left and right as a same like graph like structures, this were following some orders, right? These were following some orders, like if we see from top to bottom, the numbers which are coming in from top, we are ordering in one array, right, in one order, and same goes for left to right. So it means this is following some pattern, and which algorithm in graph, which algorithm, then I think that which algorithm in graph gives me the node in order wise. So there are this we then we know that the topological sort gives us the nodes in order, right, in order, either 3 1 2 4 5, either 1 3 4 2 5, like this. So what we will do, what we have done, we will just we will just make the orders from the connections, from the conditions which we have given, nations which we have given, named as row conditions, and order will be from above to below, and the column conditions, and its order would be from left to right. So we will just make the order using toposhot, right, using toposhot. Both will be done by toposhot. And then what we will do, we will just match from ith row to jth column. And if this row order, if the row order which we make after this ordering, the row order, ith order, is matched with is matching with the column order, we will place the value at I comma jth place, ith comma j cell, right, in matrix. Otherwise we all know that we will place otherwise we will just place zeroth zero value, right, zeroth value, right. So this is how we can form definitely a matrix, because there can be possible the numerous number of matrix, any number of matrix, the number of times it can follow any order, right. So that's how we will just form, right. So if you see, we have already seen this example 132, how this is formed, right. We just need to write the code, right. So for topological sorting, for topo short, there are two methods. One method is DFS, and one method is you can use a BFS like Q, which is also known as Kahn's algorithm. So it depends on you whether you can use DFS and BFS. Both answer will be for short. In this, I will use BFS for that. So let's see BFS. Uh, there is also a video on topological sort. You can also watch that if you want. Otherwise, I will making understanding here, right? Or you can watch this here, right? So let's start. So first thing is that we need to make the order, right, for row order and column order, right. So how we will do that? So first thing is that we need to make an order using toposhot. So, and that will be representing in an array, right. So first thing is the row order. This is row order. And second thing is column order, and this will be order comes from toposhot. So let's call a toposhot, and this will give me this will pass the row conditions, and this will be the k value, which is the number of elements which is present from 1 to k, right. And also this two arrays, numbers are from 1 to k for sure, right. It will not be greater than this k, right, or less than 1, right. Also one thing is to note that if we are not able to form this row order and column order, I am definitely sure that we are not able to make this matrix. If you see in this example, this row condition, the column to 1, the last case is, if we not able to form a topological sorting, and when we are not able to form topological sorting, when we have when we have a cyclic, like a cyclic structure, cyclic graph, right. If we when we have cyclic graph, we were we were not able to form we are not able to apply a topo shot, right, a topo shot. A turbo shot will fail. Why it was failing? See, one is will be at top of two, two will be at top of three, and three is given at top of one, and two is representing top of three, which is the same, right? This and this is same. So if you see, one is at top two, two is at above three, and three is above one. How this can possible? One is above two, two is above three. and 3 is above 1. How is it possible? It is not possible. And if you represent it in graph like structure, it is same like 1 is above 2, and 1 is representing 2, 2 is representing 3, and this 3 is again pointing to the edge 1, right? Pointing to the edge 1. So how will we, from where we will start from this edge, right? Because we need we need we need to start from, no? We need to start from somewhere, right? But here, how will, so see, this 3 is also pointing to 1, which is, I'm not able to point this. Okay, let's try this to point. So let's try to point this like 1 1 1, and I'm just trying to point this so you can visualize this. And this is 0, and this is like something like this. Okay. uh yeah, this is pointing like this, right? You can think like that, right? So this is the 3 1 is 3 is pointing to this one, right? So this is cyclic like a structure, this is cyclic like a structure, this is cyclic like a structure. So if you see, we don't have any number which has a degree 0. This 3 is pointing to 1, 1 is pointing to 2, is pointing to 3. So each one have a always degree 1, right? Each have one have degree 1. We don't have any number which had degree 2 and 0. So from where we start, we can't start from anywhere, right? So it is not possible to make a topological sort. It means it is also not possible to make a matrix here, right? So that's why we have we have centered the below array, right? Empty array, right? So if we're not able to apply topo we will just return empty matrix, right? Empty matrix, right? So this is the edge case which you need to remember, that if the topo is applying here, and if it is making a graph like a structure, we are not able to make a topo right? So just make start or topo just pass like the column conditions and the same thing. So the same the same code applicable to both row conditions and the column conditions, which is make which makes the orders follow for both of them, right? And now, if and what we need to check, that whether we are able to form an order using topo So how we will check? We will just check that if this row order should not be empty, right? It should be not empty. It means row size should be greater than 0, and also this column order should be greater than 0. And if it is no, if it is is equals to 0, if it is equals to 0, or this column order is 0, we are not able to do that, right? So what we will do, if it is greater than 0, then we will only if it is not equal to if it is equal to 0, it means we are not able to form matrix, so we will just return empty matrix from here. Otherwise, we will start iterating from I to k. We need to form we need to form a matrix of k cross k. So we need to iterate in whole k to k, and also we need to return a matrix. So we will need to make a matrix. So let's just make a matrix of size k. k. Okay, you can either initialize to 0, or you can don't initialize. It's upon you, right? So if the row order is equals to the column order, jth column, if it is both are equal, it means the matrix, the cell ij which is present, the value should be the row order will be present. Otherwise, we will just initialize it with 0, right? If both is not equal, it means we are not able to place anything. So if there is no any number, so we will place 0. So either you can write like this, or you can just initialize here, and you don't need to write like this, right? It's totally upon you, right? So I prefer this, right? So it's totally upon you. If both is equal, so you will place it. Otherwise, you don't place it, and just return matrix from here, right? So this is the final code. You just need to use a topo the same topo code which is applicable in all the generalized cases, right? So if you know topo how to implement it, this is the just code, and you just need to apply a topo shot, right? So just start initializing topo shot. So now this is the row conditions and this is the column conditions, and this is given as 1 2 and 3 to all the conditions. So just take it as a vector v, and this is the number of nodes which is present, because in the graph what is given, the number of nodes and the edges, right? So right, so what we do, we will make an adjacency graph in toposhot, which represents from vector vector and this is the adjacency, and which will and slice to the number of nodes which is present, and which we can be further from 1 to k only, or you can write it like n, the number of nodes, and you can write it like adjacency n. Totally depends on you. Now this v is representing edges here, so we will start iterating e at v, right? And now this will be, the first is 0, which will contain this one. Now this is just like a graph question, leave this, just think like this row condition is graph, this is given ages, and this is the nodes, right? 1 to 3, just think like that. Also we need to find the number of degrees for each, so let's make this out, this degree, right? This is odd degree, and this is also representing n, which is initialized to 0, right? Why I'm taking out degree not in degree, because we need to start from above to below, and the first thing is above and second thing is below, so I'm taking out degree not in degree, right? If you want to take in degree, then you need to traverse from below to, from k minus 1 to 0, right? Same goes for column conditions, right? So that's why I'm taking out degree. So what we need to do, we need to just push it this one, right? Okay, sorry, we are starting from upper part now. So if the node is pointing to someone, so this should be in degree, right? This should be in degree, right? If the in degree is 0, it means we need to start from there. If in degree is 0, we will start from there, right? So we will take in degree, right? Because if you see, uh, like this 1 and 2, and it is also representing, so from 1 to 2 it is pointing to 2, right? From 1 to 2 it is pointing to 2, so and 1 will have 0 in degree, so 2 has in degrees 1, 1 has in degree 0, this is the same, right? So we will need to take 1 degree, right? So e1 is 1 1, right? And just we will represent like this. Now we need to take a q, right? I will take a q bfs, and first thing need to push that the starting point. And what will the starting point? So the starting point will be, okay, the starting point will be the numbers which has n degrees 0. If it has n degree 0, it means we will start from there, so we will start pushing that number in my queue, right? So okay, one thing to know, that this k is started from 1 to k, not 0, right? But we have taken, and we have taken this as from 0 to n, from 0 to n minus 1, so we need to take this as n plus 1, because here it is 1 to k is included, so we need to take n plus 1. Same goes for this, this should be started from 1 until n value, right? So these things need to be taken care of according to inputs. If it is given from 0 to k minus 1, this is working, but if it is given 1 to k, you need to take n plus 1 and start from 1 to n, right? Okay, now we need to finally return a vector which is order, so we will just take it as vector answer, right? And now we will start applying iterating in q empty till q is not empty. So first thing will be node, so which is q dot front, and we will pop this out, and also we will push back in my this node as an order, right? Now what we need to do, we will just, okay, one thing is to know that we are also we also need to see that whether we have moved till all the nodes or not, right? We also need to see that whether we are whether we have find all the orders or not, right? If we can find all the orders, it means this should be we have followed all the nodes and covered all the nodes in my order, this answer, right? So we will just push back this my node, and we will iterate in its children's, right, which will represent as child, or you can represent as x, anything, right? Totally depends on implementation part. So this is adjacency nodes. Now this child, this child, this child is a part of it. So what we need to do, we need to just decrease this node point, right? This we just decrease it in degrees, sorry, in degrees, because this node is already been just. So see here in this, 3 is already just. So if 3 is removed, its in degree will be also reduced by 1, right? Because first it is a 2 in degree, then now it is will be 1 degree. So in degree will be 0, and now we will check that if its in degree is 0, it means we can take this as my in queue, because now we will perform this on operations, right? And this will be continue for again and again, right? After this, when this queue is empty, the queue got empty, I have some, I will have some values in my answer, right? So one thing to just check that whether we have got all the nodes in order or not, because I'm confirmed that 1 to k would be in order, and in row condition, the column conditions, all the nodes would be definitely present, right? So it means I need to just follow that if answer dot size, if it is not equals, if it is equals to n, so we will just return answer. Otherwise we are not able to perform topo short, we will just return this, right? And when will it happen? It will happen like if the graph, if it is become like graph like a structure, right? If it is like graph like a structure, and or it can happen that it is we don't have any conditions on any numbers, like in both the conditions it can satisfy, right? So we will just follow this answer, and if it is equals to n, it is fine. Otherwise we will just equals to this. So this gives me an order, this gives me an order for this row order and the column order, and this is how we will form. Let's just run this, and we will see, conclude after this. Okay, something. Okay, column dots order dots, right? Runtime error. Okay, let's just see what is runtime here. Okay, okay, n degree should be n plus 1, right? Because we have started from 1 to n. Yeah, we have passed the sample case. Let's just submit it. Yeah, we have passed all the test cases, right? So yeah, this is how we solve this question. Basically the question is just to know that you just need to figure out, the question is just you need to figure out that the question is of graph, right? You just need to figure out the question is of graph by seeing all these conditions, and if you follow this all the conditions by taking any example, you will observe that it is making a tree like structure or graph like structure, right? So first thing, what I have observed, see what my thinking was before solving this question, that I was thinking like this is row condition and this column structure, right? Column conditions. So when I was making these conditions, making these conditions, uh, I was writing these conditions, I was writing these conditions, it was following, it was making some graph, right? Some graph like structure, right? Some graph like structure. So I thought of to make this some graph like structure, and this is was seeing some graph like structure, so I think on that direction, right? And also above below was following the graph like structure, and we can also so I think of, so I think of this left right part to think in that direction also, right? In graph like direction, graph direction, the same that direction also. And then I think that I need some orders, right? I need some order to place. So for order, so in graph, I thought of, I thought that which algorithm, which algo gives us order of nodes, order of nodes, right? Order of nodes. So that is topo shot for sure. Topo shot, which in this is the only algorithm which gives us order, right? So, and so topo shot gives us many orders. It can give us multiple orders. It can give us multiple orders, and it can also and also and also the matrix. There can be multiple matrix possible. There can be multiple matrix possible, right? So I'm sure of that TurboShot will be applicable for both for sure, right? But how we will initialize the matrix? So I analyze that the row order which is given. If I move from left to right, the numbers which are present in the first column will come first, then two, then one, and this is the same for when we move from above to below on the column order, right? And if it is equal, it means I definitely can I equals. Then I can definitely place, right? Place it at that cell ij, right? Otherwise it is zero, right? Otherwise zero. So that was the thinking behind when I was solving this question, right? So that's the same thing which we apply. We follow the row order, the column order, and this is the same row topo shot. And when it is not possible, when topo shot is not possible, you know that if it is a cyclic structure, we can't make topo shot, right? Applicable topo shot. So this is just like a graph like structure, right? So this is how we will solve this question. Hope you understand the thinking process. Hope you understand the thinking process of solving this type of problem, for solving this type of problem, right? Okay, we haven't discussed a time complexity, right? Time and the space complexity. So time complexity would be, if you see, topo shot takes O of n, right? Because I need to iterate for each and every child. So first is for row order, O of n, column order, O of n is number of nodes, right? So this is k. Basically, this is k. Here, number of nodes is representing k, right? So this is O of k, right? And also we are moving in this row conditions and the column conditions, and also we are moving in k cross k into k for that, right? So basically, the time complexity will be definitely k into k, right? Also, the size is given, the row conditions and the column condition, which is, you can think as a ages, or you can think as n. So whichever is greater, which is given, like k is given 400, and the row condition and the column length is not given here, so you can think of ages. So let's take it as e, and let's take k as nodes, right? So so let's take k as nodes, and the e as the row conditions size, row condition size, right? Or column condition size, so either it is the O of k plus O of e. So whichever is greater than this will represent that, right? This is like O of e and O of k square for sure, right? Because we need to iterate in whole row conditions and the column conditions in this case. I don't know what will be the greater than between this. So O of k square for sure, and O of e, the size of column conditions, and this, right? So this is the time complexity. And what is the space complexity? So we need to take an extra k cross k matrix for that. So we have taken that. Also, for topo shot, we need to take a q data structure which will store all the nodes, which is can go to O of k. Also, we are taking a vector that. So O of k into k will be the space complexity overall, right? So this is time complexity and the space complexity for this problem. Hope you liked it and understand it. Thank you so much. Bye bye. Right.